By now it's also probably apparent to most of you that while it could be said that I've had a reasonably good education, it's been almost entirely in the humanities. And when it comes to the sciences, nada. So that probably explains the extra emphasis I put on this fabulous new world. And so I can remember the excitement I felt when, all on my own, I first engaged the question, are we alone? And immediately came to my own conclusion, we couldn't possibly be. I had learned that there were, well, lots of stars in our own galaxy. First, I read that there were millions, then I read there was a billion, and then I read there were billions and billions, all in our own galaxy, and then, of course, there were billions of galaxies, and so it made sense to me. Mathematically, there just had to be something else out there, and I thought that was thrilling. Almost immediately after that, though, I remember how deflated I felt when I figured out that if, in fact, this Big Bang and the dark matter conspire to have everything rushing away from us at an accelerated rate, well then, the distances were so unimaginably vast, and the time required to get from place A to place B was so eternal that it didn't matter, practically speaking. We might as well be all alone. So I went from elation to deflation. And then I figured out, and I read, that if all of that was true, the only practical way in which we might communicate to them and they might communicate to us is in our transmissions, in the signals, and that got me elated again because, boy, I put out a lot of transmissions, right? No, I mean, 30-odd years of broadcasting, 20 channels, thousands, tens of thousands of shows, and all with a little credit on it. Executive producer, Moses Nyman. I thought, okay, there's some guy up there on the planet Zork, and he's thinking, are we alone? And he's scanning the heavens, and if the timing is just right, when he's looking and we're sending and we're on the same frequency, and there's that little blinding second, and they capture it. Well, who knows? Maybe there is a planet out there where I'm a deity or something. Right? So you can see that I identified fiercely with Carl Sagan's search for extraterrestrial intelligence, and was first in line to see that movie, not that great, movie Contact, in which the Jodie Foster character played Jill Tarter. Jill is the director of the Search for Extraterrestrial Intelligence. We've begged her to come here for several years. She's agreed finally, and I welcome her to the stage.
Thank you. Now I can just give my last slide and sit down because you've given my talk. It's a real pleasure to be here, Moses, and thank you for that lovely introduction and most of my talk. So I can just sit down now, and we don't have to worry about that 20-minute timer. So are we alone? That's the big question, and Moses has given you his answer. The numbers, as Moses said, argue against us being alone in the universe. I've shown you here 2 galaxies in collision. Sounds catastrophic, but basically it's space passing through space. There's a whole lot of empty space where all those stars are as well. And within our observable universe, and of course there may be other universes that we can't observe, there are something like 100 billion of these galaxies, each one of which contains something like 100 billion stars. So we did some scientific notation earlier, that's 10 to the 22, a 1 followed by 22 zeros. So yesterday we learned that in a glass of water there are more viruses than people on the earth. Well, today I can tell you there are more stars in the sky than all the grains of sand on all the beaches of this planet. So that number is very large. And in the last couple of decades, 2 fields of study have made it perhaps a bit more bio-friendly, apparently. We've learned about exoplanets, planets orbiting other stars than the sun. We know now, I think this morning I looked, it was 294 planets in orbit around some other stars. And we've begun to really give microbes the respect that they deserve as we have studied extremophiles, organisms, usually microscopic, that live in conditions that are totally unsuited for life as we know it when we think about life as being us. But these microbes have an enormously fantastic ability to repair their DNA when it gets blasted by a large radiation dose, to live in salt, totally desiccated, to live in cold, to live well above the boiling point of water. So since my days, so long ago as a student, the realm of conditions suitable for life has expanded enormously. And so maybe there's a lot more habitable real estate out there. Whether it's inhabited only by microbes or whether there's some mathematicians, that's what I'm interested in finding out. How do you look for ET? How do you try and answer this old "are we alone" question? What we do is look for signals, either intentional or the kind of signals that Moses has been putting out for all these years. Since 1960, people talk about this great silence. Oh, you haven't found anything. Aren't you discouraged? Well, baloney. There is so much space to be explored, both three-dimensional physical space and time and frequencies and modulations. And it's just a huge nine-dimensional cosmic haystack that we're looking at. And so here's a chart. All right, this is frequency. I haven't got optical on the chart yet. This is all radio stuff. That's the fraction of sky we've looked at, and that's some measure of sensitivity. All nice bright boxes, and we all worked hard to get those boxes observed. But what do you see? What's the message in that chart? It's mostly empty. We've hardly begun to look. And that's because we need a better pitchfork for this cosmic haystack. We need better tools. We've been using the tools of the astronomers suited for looking for astrophysical signals. We need our own tools. And here's the newest pitchfork in our armory. It's the Allen Telescope Array, Hat Creek in Northern California. It's the first attempt to build an array, the equivalent of a very large radio telescope, by using a lot of small pieces and consumer off-the-shelf technologies to keep it cheap. So this is a large N small d array, and it's all because of silicon computing that allows us to combine all these signals together today in a way that we never could before. And last October, this gentleman here, Paul G. Allen, for whom the telescope is named, came to Northern California, and he pushed a button and the telescope began its operational life. So I spent the last decade trying to observe stars in that little sphere as part of this large Milky Way galaxy, which is 100,000 light years across, and we've observed out to about 150 light years, 1,000 stars. In the next decade, with new technologies, we'll do million stars. We'll look towards the center of the galaxy at collections of large numbers of stars, and we will expand the search enormously. Now, I think it's important to do this, and I think the best reason is summarized by this statement by Phil Morrison. SETI is the archaeology of the future. It's archaeology because the finite speed of light means the signal's taken a while to get here, so we're learning about their past. But the reception of a signal tells us that it's possible for us to have a long future. That's because unless technological civilizations live for a long time, SETI won't succeed. It's a very quick cartoon diagram of technology over time. We didn't have any that was detectable over interstellar distances for a while. Right now, it's expanding exponentially. In nature, every time we get an exponent, it turns over because of some source function or limitation in raw materials. But in fact, as Ray Kurzweil will tell you, this exponent may just keep going. and a singularity, and we may turn into the machines. But either way, the most probable place to find a technology is in its old age. You can't find it when it's in its infancy. The exponential period may be short, and so any detectable signal out there will be from an older technology. If this is the right graph for technology, then basically we won't succeed. So we're now looking at the question of, if everybody's listening and nobody's transmitting, we're in trouble. So should we broadcast? Well, we can't answer these questions in a reasonable way. Who should speak for Earth? Moses already has, right? What should they say? Transmission takes global cooperation and long time scales. You don't transmit for 2 years and expect your signal's going to be found. And we're not very good at 10,000-year plans yet. So what we need to realize is that we are a very young technology in a very old galaxy. Let's do the simple thing first of listen. When we get to be old, we can take on the harder job. So we have before us the cosmos to explore, and what if sometime our lonely planet, looking at another planetary system which has a radio telescope and we have a receiver, detects a signal? What if? Well, I think the most important thing about that signal is that it will put up a mirror to the planet, to all humans, to show us how alike we are, how different we are from another independently evolved technology. And so I think SETI is fabulously important because it offers us a different point of view. It really does make us step back, take a more cosmic perspective, and it trivializes the differences among humans that we seem to be willing to kill one another over. So I don't know if SETI will ever succeed. I don't know if we are alone. Phil Morrison, once again, is the author of the most wise thing that I've ever heard on this topic. Probability of success is difficult to estimate, but if we never search, the chance of success is 0. So please stay tuned, because we're going to keep searching. And in your bags, you found this Explorer magazine, because SETI shouldn't be done in the US or California. It should be international intrinsically, and we'd love to give you the opportunity to participate. So if you're interested in this work, you can join Team SETI. You can adopt one of our scientists and go on a field trip. And yeah, Moses, the telescopes are for sale. And that's important, actually, as you'll learn from the next couple of talks, because we're going to use this telescope to downlink signals from successful contestants in the Google Lunar X Prize. And the more telescopes we have on the ground, the higher data rate we can get from their missions on the moon. So, lastly, I'd like to invite you to come visit us. Thank you.
Splendid. And I'm going to take you up on your offer. I'd like to come and visit.
Oh, thank you.